Okay, we're going to look at solving systems of nonlinear equations next. So nonlinear, meaning that they are not equations of lines, or not both of them are, one of them might be. So if we look at question number 1, to solve this system, the first equation is going to be a parabola. And the second equation here, we do have a line. So it says we want to solve these algebraically and then graph the system to verify. So algebraically, we normally use either our substitution or elimination. So because I have the y equals, it makes me want to use substitution. So I'm going to take this entire expression here and plug it in for the y. So that'll be negative x squared plus 3, and then I'll keep the minus 2x equals 0. So that was my substitution. So then at this point, you should have an equation with only one variable that you should be able to solve. And looking at it, I have a quadratic. Now I don't like the negativity in there, so I want to move everything to the other side of the equation. So that's going to be add the x squared over minus the 3, add the 2x. So again, that's x squared, add the 2x minus the 3. So I have x squared plus 2x minus 3. And that's a quadratic equation. You can solve that by using the quadratic formula or by factoring. I'll try factoring. So we have x times x makes x squared. If I put a 3 and a 1, that makes 3, but I need negative 3, but I have to add to a positive 2. So a positive 3 and negative 1 will work. So this means that either x plus 3 is 0, so x is negative 3, or I have x minus 1 is 0, so then x is equal to positive 1. So those are my x values, but I need to find the corresponding y value. So if my x value is negative 3, in order to find the y value, I can take this and plug it in either to equation 1 or 2. Kind of looking at equation 1 because it already says y equals. So I'm going to write y equals negative. I'm going to plug in that negative 3 right in for x. And so then that ends up being, if I square that negative 3, that's 9. So I have negative 9 plus 3, which equals negative 6. So what I have then is, the negative 3 gets me a negative 6. So there's one ordered pair that satisfies both of those equations. Then I'm going to do it again. This time I'm going to plug in x equals 1. Again, still plugging into the original first equation. So we have y is equal to negative. We're going to stick a 1 in there. And so when you square the 1, you get 1. So this is negative 1 plus 3. So we get 2. So our point would be an x value of 1 gets me a y value of 2. So those are my two ordered pairs. And so what that means is that both of those satisfy those two equations. So graphically, if I graph these equations, which the first one I have was that y equals negative x squared plus 3, that's shifting it up 3 and reflecting it across the x-axis. So I'm going to go up to 3 and then reflect it. So that's going to be my graph of my parabola. Now they're not perfect sketches. That's why it's really nice to do the algebra and then kind of check graphically what's going on. So the other equation I have is y minus 2x equals 0, but I want it y equals, so I'm going to write y equals, move the 2x over, I get y equals 2x. So this is just a line. There's nothing added, so we don't have any shifting up and down, so we know the y-intercept is at 0, and our slope is going to be 2 over 1, or our stretch is by 2. So I start at 0, 0, and I go up 2 over 1, up 2 over 1. I can go down 2, left 1, down 2, left 1, down 2, left 1. So my graph isn't too bad, freehand. So this is going. So it looks like they meet at this point and then also at this point. And I can identify the coordinates. This one looks like 1, 2, and this one looks like negative 3. It's kind of hard to tell. But looking back at my algebra, that should have been negative 3, negative 6. So maybe just a little bit lower on that one. But pretty close. So the graph is just kind of to back up or to kind of verify what I did with the algebra, but you can see that my graphs intersect each other at 2 points. Okay, we're going to try that again. So maybe you try by yourself first, do the algebra, and then check with the graph, then check with the video. So you should pause and try. So now that you've tried, let's see, we have this system we want to solve. We're going to do substitution again because we have y equals, so this square root of x minus 2 is going to be able to go in place of y. So that'll look like x squared plus, we're going to take that whole thing and square it in just a moment. That's going to be the square root of x minus 2. We're going to square that. So when you square that, this ends up being x squared plus, it undoes the radical, so we'll have an x minus 2 there, equal to 10. This is a quadratic, so I need it to be equal to 0. I'm going to move the 10 over. That's x squared plus x minus 12 equals 0. Again, we'll solve by either, you can factor or use quadratic formula, whichever you'd like. So I'm going to factor again because it is factorable. So 4 times 3 makes 12. That'll be a positive 4 and a negative 3 equal to 0. So that means either x plus 4 is 0 or x minus 3 is 0. So I'm going to get x equals negative 4 and also x is equal to 3. So just like before, we got to find the corresponding y that will also work for that. So if I go and I try and plug this in, let's plug in back to the beginning again. We're looking at y equals the square root of that negative 4 minus 2. Well, that's going to make me have a negative number, which isn't real, so that's not going to be on our graph. Now, if I plug in a 3, that's y equals the square root of 3 minus 2. That's y equals the square root of 1, which is 1, which that could be on our graph. So it looks like the only point they have in common, these two equations, would be the point 3,1. So let's check that with our graph. So the first thing we want to graph is the y equals square root of x minus 2, which is a radical equation. That's that guy. And this is shifting him to the right 2 spaces. So if I go to the right 2 and then kind of have that guy shooting off, that's my picture. Now the other equation we have is x squared plus y squared equals 10, and that's a circle. It's centered at 0, 0, and our radius is going to be the square root of 10, which that's going to be like 3 point something because it's a little more than the square root of 9. So let's see what that looks like at 0, 0. I'm going to go 1, 2, 3, up a little bit, 1, 2, 3, a little bit, 1, 2, 3, a little bit, 1, 2, 3, a little bit. And I'm going to draw my circle. And as you can see, it is only meeting at 1 point, so that looks good so far with my algebra. And it looks like the point where they meet at is right here, which looks really close to 3, 1, which, yay, that was what I got algebraically. So it looked like we did good. That verified our solution. All right, flipping over the page, we have another one. This one, it doesn't say to graph it, so we're just going to solve it algebraically. Now this has y equals something and y equals something, so I'm going to still do substitution. It's really set up for that. So this x squared minus 6x plus 9 is going to get substituted in for the y in the second equation. So that will look like x squared minus 6x plus 9 is equal to negative 2x plus 5. Now, I'm not going to full out graph it, but just kind of thinking about the picture. The first equation is some sort of parabola, and the bottom equation is a line, so it looks like we might have 2 points where they meet at. I mean, it could be 1 point if it was something like that, or maybe it only touched it at one little point. I'm not sure, but at most we would have 2 points where they met at. So looking back at our equation, we have that it's a quadratic, so I want to make it equal to 0, so I'm going to move the 2x over and the 5. Move the 2x over and the 5. And so we have x squared minus 4x plus 4 equals 0. And so this looks like it will factor to x minus 2 times x minus 2 equal to 0. And that gets me x is equal to 2. So it actually looks like we have the situation here where we're only going to touch at the 1 point. So if I want to find the y value for that, I'm going to plug in to, let's see, the second equation looks a little easier. So we'll have y equals negative 2. We'll plug that in, plus 5. That's negative 4 plus 5. So y will equal 1. So the point where these two things intersect is going to be 2, 1. And you could double check that on Desmos if you want to, or you can graph it by hand. But I just checked it really quick, and it is doing exactly that. It's meeting at that 1 point, which would be 2, 1. Okay, so we have one more problem here. It says that we have the sum, which means add, of the square, so power 2, of two negative numbers is 145. The difference of the squares is 17. We need to find the two numbers. So we're going to add up two numbers. We're going to say the numbers are x and y. And so if we take x squared plus y squared, that's supposed to be 145. Now it's telling us they're supposed to be negative. We don't have to put a negative in anywhere. We can just say x and y, but know that when we look at our answers, those have to be negatives, because x and y doesn't necessarily mean anything about being positive or not. So x squared minus y squared, their difference was supposed to be 17. So this is a system we want to solve. Now this equation doesn't have like y equals or x equals, so nice. So it's actually, this one is set up to use the elimination method. So if you look at, if I add the equations together, the y squareds would end up canceling out. So let's do that. We're going to eliminate the y. So here we have x squared plus x squared. That's 2x squared. 145 plus 17 is going to be equal to 162. So now we have an equation that only has one variable, so we'll solve this for x. We'll divide by 2, divide by 2. We get x squared equals 81. We square root. So then x is going to be equal to, now don't forget this, it's both plus and minus 9. And that's important because if I don't put that minus, I'm not going to get any negative numbers, which is what it was telling me I'm working with. So we're only going to use that x equals -9. We don't have to use both of those x values. If it was not an equation asking us for those particular negatives, then we would have to use both and then find the corresponding y. So if x is equal to -9, you can plug into either equation. So if I look at just the top equation, which was that x squared plus y squared equals 145. Again, I'm trying to find the y. I need to plug it in to x, square it. And so this is looking at, I have 81 plus y squared equals 145. We'll subtract the 81. So we get y squared equals, if we take 145 minus the 81, we're at 64. So again, we square root, we get y equals both the plus and the minus 8. So it looks like a -9 is supposed to go with 8, and -9 is supposed to go with -8. Now again, I'm going back to the original word problem, and it only wanted the negative numbers, so I'm not going to use that other guy. So then this is going to be my x and my y. So the numbers that it asked me for are -9 and -8. And you can double check them back in the words of the original word problem to make sure that they both work, and they do.